The goal of this video is to determine whether or not a set of points, that is a set of ordered pairs, defines a function. So the question is, do the following sets of ordered pairs make functions of x? What are their domain and ranges? All right, so with this first set of points, we have the following points: 2, 3, 4, 1, 3, -2, and 2, -1. So to determine whether or not it's a function, you want to look at all of the x values. I'm just going to underline them here. So we have 2, 4, 3, and 2. Okay, so you want to ask yourself, did any of those repeat? And indeed they did, right? We've got a 2 here and a 2 here. Now, that doesn't necessarily mean it's not a function, but you got to look at the y values. I notice for this first point of 2, 3, our y value is 3, and for the other point, 2, -1, our y value is -1. Because those y values are different, this isn't a function. So if you think about the function machine, right, and you're thinking about the input and the output, there can only be one input and there can only be one output. So if we have an input of 2, what's going to pop out as an output? We have 3 and -1. We can't have both, right? It's not a function. Is this set of ordered pairs a function of x? No, it's not, because we have a value in the domain, right, an input of 2 that's corresponding to two different outputs, right? 3 and -1. Okay, so this disobeys the rule for a function. Now, we can still state the domain and range as the set of all inputs and the set of all outputs, even though technically it's not a function. So what are the x values here? Well, we have 2, 3, and 4. Even though 2 is listed twice, just list it once in the domain. And the range values, let's see, -2, -1, 1, and 3. So I'm just listing all of the y values that are present there. You don't have to list them in order, but I think it's nicer on the eye to do so. Okay, so let's look at this other set that we're given. So we've got the points -2, 3, 4, 1, 3, -2, and 2, -1. So this set of points, actually, it looks almost identical to the first example, right? Except for one key difference. And that is at this first point, it isn't 2, 3, it's -2, 3. So what happens? I mean, when we're looking at all of the x values, are any of them repeated? Do we have any value of x that appears twice in this set? No, we don't. And so this is technically a function, right? For every value of x, it corresponds to exactly one value of y. None of the y values repeat, but even if they did, it's fine. That's like two different people having the same birthday. That's all right. We just can't have a person with two different birthdays, right? So we would say, yes, this is a function. The domain is -2, 2, 3, and 4. And the range, the set of all outputs, which are the y values. What's our lowest y value here? It's the same as it was in the first example, right? Yeah, values of y. Okay, also notice with the domain and range of these problems, I'm just listing the only values of x and y respectively that I can. And all you have to do is list them in the set brackets. And you don't even need to say the set of all x such that or anything of that nature. If you're just listing specific numbers, you can just list them in a set. Okay, now along the same lines, this is the same kind of problem, it just looks a little bit different. So in this case, we're trying to determine whether or not each of the following tables could be a table of a function and explain why or why not. So in both of these examples, we've got a table of values, and essentially it's the same thing as having a set of ordered pairs, isn't it, right? Like in this first example, I've got a column of inputs and a column of outputs. So that's the same thing as saying, okay, -1, 4 is a point on this function, 0, 7 is a point on the function, 1, -3, etc. So I'm looking at the input values, right? That's really where I'm at. We're looking at those input values, and do I see any input value that's listed twice? I've got -1, 0, 1, 2, 3. Nope, They're all different, right? Now I notice in my output values, I have an output of 4 that's listed twice, but that's okay. If I stick -1 into the function, I get an output of 4. If I stick 2 into the function, I get an output of 4. But I'm only getting one output for each of those inputs that I listed. So I'm going to say, yes, this is a function. Each input corresponds to exactly one output. Okay, so for the second example, again, I'm looking at the input values. So -5, 0, -1, -2, -5. Okay, I just listed -5 twice. Okay, and look at the output value. So for -5, I could have 4 or 7, right? So I'm going to say no, this isn't a function. For an input of -5, there are 2 possible outputs. 4 or 7, right? So that's what you want to be looking for with any set of points, whether you have a table or just a listed set of ordered pairs. Do any of the x values repeat in a way that you get 2 different values of y corresponding to that value of x?